All right, my friends, let's jump to the fourth partial sum. It would simply be what we had for the third partial sum plus, the fourth term there, so 30. Fifth partial sum, 31, because we're hugging in the 1. And that's all that was asked for, really, 16, 24, 28, 30, 31. Now, real quick, let's talk about what a partial sum is even for. A partial sum, or a series of partial sums anyway, is typically used to give an educated guess as to what the infinite sum would be. So, what is this whole thing equal to, right? If you add up infinitely many terms. And so sometimes, even though they asked for just the fifth partial sum, you might actually look at a couple more. So like sixth partial would be 31 and a half. Seventh partial would be 31 and 3/4, and so on. And so, so if somebody was to say, quick guess, what would the infinite sum be? Which typically they just use an S for that. So what would, if you add up all these terms, including the ones at the end there, what's your guess as to what you'd get? And I think a lot of people would guess 32. 32 and infinity are two really common guesses. Anyway, so if you guessed anything between 32 and infinity, I'd say you're doing pretty good. Anyway, but in this lesson, we'll basically show that if you're not convinced yet that the answer is 32, we'll try to convince you that the answer to that one is 32. But for now, let's go ahead and check and see what you did for part B over here. So for part B, basically this time you just keep multiplying by 2's to get your terms. So the first term, just plug 1 in for n, you'd have 1/16 times 2, which would be 1/8. Let's see, next let's plug in a 2. So you'd have 1/16 times 2 squared, 1/4, and really you just keep multiplying by another 2. So 1/2, 1, 2, 4, 8, 16, etc. Okay, so what would your first partial sum be? It would just be 1/8. Second partial sum would be 1/8 plus 1/4. Was that 3/8? Fractions. Third partial sum would be 7/8. Fourth partial sum would be 1 7/8. Fifth partial sum would be 3 7/8. And really, since we expanded the terms, I hope it makes sense that if somebody says, quick, guess what the infinite sum would be, I hope it makes sense that here the answer is definitely going to be infinity. Because, I mean, for goodness sakes, the terms themselves are approaching infinity, and you're adding up infinitely many of them anyway. So I hope it makes sense the answer to this one would definitely be infinity. All right, my friends. So let's talk about geometric series, which is another main point of this lesson that we'll get a ton of mileage of throughout Chapter 8 and on your AP exam. So first, what is a geometric series? A geometric series is simply a series where to generate the terms, you just keep multiplying by the same constant value. So notice that for part A, we really just kept multiplying by 1/2 every time to generate new terms. And for part B, we kept multiplying by 2 to generate new terms. So we would say that for part A, you had a geometric series and it had a common ratio of 1/2. And for part B, we would say you had a geometric series and your common ratio is 2. All right, my friends, in addition to being able to identify what is a geometric series and what isn't, and what a common ratio is, we're also supposed to be able to use a certain formula that could be used to get answers for certain geometric series. So the formula that we're going to talk about next is for the infinite sum of a geometric series. Okay, and I know that most of you have learned this before in a pre-calculus class. Now, do you remember it or not? That is negotiable. But here, I'll help you. Infinite sum equals, Anyway, see if between now and the next video, if you can scratch your head and remember this formula or not. Either way, I'll help you with it in the next video, but see if you can remember it and check in with me next.